Good morning. This video is 5-3 notes examples with a Crook problem. How to do a Crook problem. Okay, so the first thing we're going to start off with is 5-3 notes. So 5-3, okay, is parallel lines. So parallel lines. All right, and really the 8 angles making 5 special pairs those 5 special pairs are alternate interiors, alternate exteriors, same side interior, same side exterior, and corresponding angles. Okay? Now from these 5 special pairs, we have 10 theorems. Okay, so those 10 theorems are really 5 theorems and the converses. So there's 5 theorems with 5 converses. And those 10 theorems are on the Schoology page, which is for 8th period. They're both 8th and 3rd period. It says the video 4-5 to 5-3 10 theorems from 2 lines cut by a transversal. So you should watch that video, take notes on it, and that's going to help a lot in learning these. Okay? So 5-3, okay, here's 2 examples with 5-3, which is really 5-2, 5-3, 4-4, 4-5. They're all related to this. So in 5-3, example 1, there's a proof here, and the proof looks like this. Oops. All right, and it's R here, S here, N here, P here, 5 here, and 6 here. So you're given that angle 5 congruent to angle 6, and you're also given that RS is parallel to NP. And we want to prove that triangle NPR is isosceles. Okay, so in order to do that, we need to do a 2-column proof. But let's talk about it before. Angle 5 is congruent to angle 6. And if you don't recognize it yet, RS is parallel to NP. You should extend this here. You should extend NP a little bit to see it. And then you should also see your 2 transversals. Here's one transversal, and here's another transversal. Okay? So when you see these 2 transversals, our hope is that you can see that this angle and this angle are alternate interior angles. And then you can also see that this angle is congruent to this angle for the same reason. If the lines are parallel, the alternate interior angles are congruent. Now the converse is true, but we're not going to use the converse because we want to get the angles congruent. We already have the lines parallel. So that's what we have to do. We have to say angle 6 is congruent to this angle, angle 5 is congruent to this angle, and these 2 angles are congruent because of the transitive property. Okay? And then if we get these 2 base angles congruent, we can get this triangle isosceles. So in order to get that done, we'll write out our first given. we're going to need these two givens to get these two angles. So angle 5 is congruent to angle 6, that's given. And the second given is that RS is parallel to NP. Now that's going to tell us that angle RNP is congruent to angle RPN. Because if the lines are parallel, the alternate interior angles are congruent. Now, angle RNP, is congruent to not RPM, but angle 5. Okay, RNP is congruent to angle 5. And then the fourth step would be that angle RPN is congruent to angle 6. And that is the same as 3. Okay, now RNP is congruent to RPN by transitive property. Angle RNP is congruent to angle RPN by the transitive property. That tells us that the triangle is isosceles now. So it was triangle NPR. Triangle NPR is isosceles. So if base angles congruent, then the triangle is isosceles. Okay. So that's the example for the proof, okay? And let's do one more example from 5.3 now. This is not a proof, okay? Example 2 is looking like this. A parallel to B, all right? Find the measure of angle 1. So here's A, line A. Here's line B. They're parallel, so we'll put a little symbol there. And then it's going to be cut by a transversal. And this angle is 2x plus 5. And this angle is 3x minus 13. Okay, and here's angle 1. So these two angles need to be recognized as corresponding angles. And here's the F that you can see with the corresponding angles. One in, one out, same side of the transversal. So 2x plus 5, the equation from the facts is 2x plus 5 equals 3x minus 13. All right, when we solve for x in this problem, we get x equals 18. And if we substitute x equals 18 into this angle, we will find angle 1 because they're vertical angles. So 2 times 18 plus 5 is 41. Wait. 41. Yep. Okay. So this one was not a proof, but it was an example from 5.3. Okay? Now, the Crook problem, how to. Now here's a Crook problem. Let me pick one here. I got one on a Word document I think I had here. I can just take a picture of it real quick. Here they are. Maybe I'll do a different one here. So I'm going to do a harder one. Okay. So I think we'll start. We'll do this. Maybe we'll do number 7. That's a good one to do. Okay. Okay. So the first thing you want to do with these Crook problems is you want to draw auxiliary parallel lines through the crooks. So the crooks here are this problem, or this crook, and this crook. So I'm going to draw some auxiliary parallel lines. This is 1, and this is 2, and it looks like I have a third one here. That's a little tricky. Okay? Now, the second thing you want to do when you do these is you want to work your way to the variable. So work your way to variable. Okay, using the 10 theorems. Really only 5, but we want to make sure that we remember there are 10. Okay? So in this problem, it's 137 here. Now I know that this angle and this angle are same side interior. And if the lines are parallel, the same side interior angles are supplementary. So this angle is 43 degrees. Now, this angle here, okay, is 43 plus this angle make up 87, okay? So 87 minus 43, which is equal to 44, is the measure of this angle, okay? Now, it's a little tight, but this angle and this angle here are alternate interior angles. So that makes this angle 44 degrees here. Okay, so I don't know the measure of this angle yet because this angle is unknown, the big one is unknown. So what I have to do now is sort of work my way from the top now. So I look at this angle, and they are same side interiors. So then this angle is 32 degrees. So this angle is 47, or is it 41 or 47? Okay, it's 41. Okay, so that makes this angle here 9 degrees. Now this angle, the 9-degree angle, and this angle are alternate interiors from this transversal, see? Okay? So that makes this angle 9 degrees too. Now we found angle Z. Because angle Z, I covered it up there a little bit, is 44 degrees plus 9 degrees. Okay? So 53 degrees. Okay, so the crook problems, we draw parallel lines through the crooks, and then we work your way to the variables using the 10 theorems. In this problem, we use same side interior supplements and alternate interior congruent. All right, so there's a crook problem. And then 5.3 was using the 10 theorems. If the lines are parallel, the corresponding angles are congruent. And we get the equation, and the proof was the proof. Okay, so good luck and have a good day.